Welcome, Noah, and welcome, Jeremy. How are you folks doing?
I am great. I'm excited. How are you?
I'm doing well. It's like I think my fourth or fifth cup of coffee because, I need to do this for about 8 hours. So yeah, I'm good. Pretty hyped. Pretty good on caffeine. So nothing to worry about. How are you, Jeremy?
Yeah, pretty good. Probably gonna need a cup of coffee as well.
Yeah. So or the coffee or the other stuff can be quite aligning as well. But stay hydrated. Drink water. Anyway, we're going to talk about Go development, if I'm not mistaken. And Noah, you will talking about becoming a secure developer in Go. Well, I have never done any Golang or Go. What is the right way to pronounce it? Is it Go or Golang? I'm always
Um,
confused.
Both are correct, to
B-
be honest.
what is the preferred way? Go or Golang? Or doesn't
So
matter?
we have Jeremy here, who is a Go expert,
Yeah,
to be
I would
honest.
probably go with Go.
You probably will with Go, but yeah, Go can be confusing if you're talking about the language, the game, or whatever it might be, right?
Yeah, that's true. But then, I mean, you can always precise. But yeah, I would go with Go.
Okay, let's go with Go. Let's call it Go, and that's what the actual title is about. Noah, I guess you have a slide deck or a demo, or let's start sharing your screen so I can put it on. And in the meantime, folks, while Noah is doing this, um, make sure that you're asking your questions or comments in the comment section of either your YouTube or your Twitch stream. I can direct them to Jeremy and Noah, or I can answer them myself, or somebody from the team can answer them while they are there because they are backstage. Well, not here, literally backstage, but virtually backstage to help you out. So amazing, becoming a secure developer in Go. And Noah, go for it. Take it away. And if you need any help, any questions in the meantime, I'm here. Jeremy is here. Feel free to ask us. If something is not working, hey, it's a live stream. Things go wrong. I already did a demo that went completely south, so no worries.
Great. So, hi, everyone. Welcome to my session. I'm excited to be here. So, today's session is becoming a secure developer in Go. Um, my name is Noah. As Brian said, I'm a solution engineer at Snyk. And we have 5 topics to cover. So we will discuss using Go standard crypto packages over third-party ones, using HTML templates to avoid cross-site scripting attack, secure your third-party code, sanitizing all input data passed in or out of a subshell, and of course, deploying your code securely. So why would you want to encrypt your data? Feel free to write in the chat more answers. These are the 4 ones that I chose. So obviously we want to avoid data breaches. We want to keep our data safe in transmission, meaning we need to encode it before. We want to guarantee the data's integrity. So obviously we want our data to be relevant and accurate. And of course, everyone has to meet regulatory requirements. So those are just 4 that I wrote here. Obviously, if you have any other ideas, you can write them in the chat. So Go actually has a standard crypto package library. So, and you should use those because they're well audited by security researchers. And so they might not be all inclusive, and you may want to use open source ones. But just like you're not going to write your own crypto algorithms at the moment because it's very difficult. So you shouldn't be using the third-party ones as well. So when you are using crypto packages, know your sources and just use the standard crypto packages. Next, so use the HTML template to avoid cross-site scripting attacks. This is especially for users. So if you use the IO write string or the text template packages, they can actually cause cross-site scripting attacks. So this is because the HTML tags will be rendered without any encoding. And it may also be sent with an incorrect defined content type plain text response header if it's not explicitly set. So what we should use instead of that, we should be using the HTML template package. It's a simple way to automatically web encode content returned. And instead of, trying to do this manually in your application logic, you can use the HTML template. And if you want to read more about this, you can go to OWASP Go SCP, and they have great documentations and examples about this specific topic. So if you do use other third-party libraries, you should make sure that your open source that you're using is safe. And you can use tools, for example, Snyk, which can test your application, continuously monitor it, and even give you remediation advice. This can be done in the GitHub integration, in CLI, or even in the pipeline, where you can break a build based on the exit code it will return. And we also have Snyk Advisory, which recently has support in Go. So I just want to show you what that would look like. This is a Snyk Advisor. Here you can actually go and find libraries before using them. So I'm going to use the GoRM library. And for those who don't know, this is an object relation mapping library, and it's just a technique to convert data types that are incompatible. So over here, we can see that the package health is extremely good. It's 97 out of 100. We see it's very popular. The maintenance is great. No security issues, and the community is very active. And if we go down, we see that the latest version was actually released 6 days ago. So that's pretty active. That sounds pretty active to me. And if you want to see previous versions and to see if they're vulnerable or not, I can go over here. And this is going to take me to Snyk's database. And we see that all versions under 0.2 actually have a vulnerability in SQL injection. And if I click further to investigate this further, I can see that this is the reason it's a critical issue. So we see the common vulnerability scoring system over here based on these. So the Snyk Advisor, we can just, before we use dependencies or libraries, we can go check out their health score first. So what I want to do is I want to do a demo. So we're going to use a vulnerable app. If you want to follow along with me, you can go to my GitHub, Noa Moshe. It's using Hello UTF-16. That's the app. We're going to exploit it. We're going to use Snyk to find issues and obviously remediate it. And then we're going to retest and see that the vulnerability is gone. So over here, so I have 3 tabs open. The first one, I'm going to be running my application. It's listening on port 8080. And over here, I already did ls, so we can see the files that I have over here. So I'm going to copy I have the commands on my other screen. I'm just going to copy so it doesn't take a lot of time. So the application takes UTF-16 and it returns it in UTF-8. And we can see that my world.txt is just world in UTF-16. So I'm going to run it, give it as input to my application. And as expected, it returned hello, world. And I see I have this other file. I have dos.txt. So I'm going to try and use that one. And nothing is happening. So let's see over here. It's still listening, but nothing is happening. So let me check my CPU usage. And I see that this is the one that's taking the most CPU, my hello UTF-16. So, okay, something is wrong, and I'm just going to stop it from running. And I'm going to run Snyk monitor to check out what's going on. So if I haven't explained it earlier, Snyk monitor is going to create a snapshot of the dependencies that are in my application and send it to Snyk's UI to find any vulnerabilities in that. So I am going to bring this. It opened on my other screen. Okay, so I see that I have one vulnerability. If I look at my dependencies tab, I can see all the dependencies in my project, but specifically, this is the vulnerable one. So if I go back here, I can see that I'm using version 0.32, and this is vulnerable, and I can fix it if I just upgrade it to 0.33. Sounds simple enough. Let's give it a go. So I'm going to go back here, stop it from listening, and upgrade my my dependency. Cool. So now I'm going to build my project again. Okay, so now let's try to rerun this. So I'm going to run my application again. It's listening. And we're going to run the same command with a dos.txt. Okay, so the issue was fixed. If we look into the file, we can see that it was just an empty string. And this empty string caused a denial of service. So I had to either go to the advisory and check out this dependency before using it, or I could also run Snyk monitor to see that the dependencies and their issues. So now that I saw my application is fixed, I'm just gonna make sure and run Snyk test to make sure I have no more issues. And I can see we tested 7 dependencies for known issues, and there are no vulnerable paths. My application is secure. I can continue using it safely. Okay, cool. So this is my next slide anyway. Yeah. This slide is kind of specific for all languages. Don't forget to sanitize all inputs, obviously. But specifically for Go, in Go, a subshell gives you direct shell access to your system. And you need to sanitize external data that is passed and data that is returned. So putting a call to run to the external process as part of the application request thread could have other side effects that cannot be controlled in your Go code. And that could be, for example, changes to your actual file system and calls to external dependencies. So sanitize all input, always. So in case we missed some cross-site scripting issues or SQL injections, and they come from our custom code or proprietary code, Snyk code actually has support for Go. And for those who don't know what Snyk code is our static analyzer. So you can use it to scan your first-party code with Go. So as we said, it finds issues in your first-party code. You get the data flow from the source all the way to the sink, and you get details about the issues along with fixed examples. So I'm going to go to my project. I scanned Snyk over here with my GitHub project, with my GitHub integration. And I have, this is my open source project. It's looking at my Go mod, and I can see here my code analysis. So let me enter my code analysis, and I see I have 11 static issues in my custom code. So I can see SQL injection. That's an interesting one. So let me open this up. On one hand, we have the actual code, and this is being lazy loaded from the GitHub integration into the system, so you can have it side by side. And on the left, we have the source all the way to the sink with steps. So if it changes variables, goes through functions, you will see that in your code. And this is awesome because instead of me going to the file and trying to figure out in this entire file of 164 lines, I can know exactly what line I need to look at. So once I understood the flow of this issue, I can go to the fix analysis section. I can understand more about SQL injection. What is SQL injection? What are best practices for preventing this issue? So I can see over here and read and get a better understanding of that. And finally, I have fix analysis example fixes. And these are SQL injection issues that we found in open source projects. And this is how real people actually fix these issues. So we have these 2 examples, the first and the second, and I can understand from this, get an idea of how this issue needs to be solved, and then go to my IDE and actually fix it. Great, so that was the static code analysis. And lastly, we want to deploy our code securely. So you may be using Kubernetes to deploy your files, or I know CDK, very popular on AWS. And you can actually write the CDK in Go, and that will be transformed into CloudFormation. So the CloudFormation file is something we can scan for and find misconfigurations along with Kubernetes files, Terraform, and Helm. So those misconfigurations, you will get the misconfiguration, what line it's at, what's the issue, how you can solve it. And this helps you identify major security vulnerabilities before you actually deploy them. So that's super helpful. And I actually have a project over here as well. So we scan CloudFormation projects. And once you click on them, you would see here, same concept as a static code analysis, as in we have the file on one side, the issues on the other, and we can see what the issue is, what's the impact of it, and how we can actually resolve this. So next step from me to you, log into Snyk, open a free account, start testing, start finding those vulnerabilities, whether it's my Hello UTF-16 application or your own code, test. I also added here the Go crypto library links, the Go 8 best practices, which some of what I said today is also there, and our Snyk support for Golang. So develop fast, stay secure, and start fixing. Back to you, Brian.
All right. Thank you, Noah. I mean, that was quick, concise. You hacked something and you fixed it, and that within 17 minutes. Wow. If you weren't already hired with Snyk, I would hire you right now. Anyway, I appreciate this so much. But just a general question from my side, and either maybe you can answer it, Noah, or maybe Jeremy can. I mean, I hear a lot about Go, the language Go. We support Go. Just ballpark. How big is Go nowadays? I mean, I'm an old-fashioned Java developer doing that back in the days. Like how we looked 10 years ago to C developers, now people look at Java developers this way. Go is the new kid on the block, so I feel. But is it really that big?
Yeah, I can probably take that one. Yeah, with cloud native solutions, Go is becoming bigger and bigger. And with new releases coming up every 6 months, there are new features in the Go standard libraries that I would use, like Noah said. So yeah, I think it's very easy to deploy Go services nowadays in cloud native solution in Kubernetes. It's CPU efficient, it's memory efficient. So those are the key threats of that language.
So we are trying to get before the big curve and make sure that we already support this. Now it's getting bigger and bigger, which is great. One of the things I wanted to ask you as well, Noah, like how you're a product manager, or like how do you came into this world, into the whole tech scene? Just, I mean, your presentation was splendid and spot on. So I just want to know what your journey was, just quickly.
Yep. So I'm actually a solution engineer. I will be moving to products very soon. But I started computer science. I was like, I love this tech. It's super interesting to me. Then I met the cyber world through Snyk, to be honest. My first position. So yeah, that's a very quick story.
Well, very quick story, but you're here now, and I loved what you showed us. Quick question to you, Noah. Can you please put we have a private chat for everybody that is in this thing. Can you put the link to that repository in there? Because I'm super curious and I just want to try this myself. I am not a Go programmer, but I try to do as many languages as possible nowadays, and this one is still on my to-do list. Let me share that to, if you're okay with that. It's an open GitHub. Let me share that to everybody else who wants to try this. Is it okay?
Yeah, of course.
So let me put that in the chat for both YouTube, Twitch, and DevSec on YouTube. And if you're not there, this is the GitHub repository to reproduce that hack that Noah just showed us. Go as a new language, and again, I leave it up to you who answers this. Is it just a feeling? And this is a very hard one to answer, but there's always the thing you get like, hey, it's a new language. Is this language more secure than any of the older languages like JavaScript, Java, Python? Basically, is that one of the reasons why I should switch to Go, or do you believe that, for instance, the memory efficiency is a bit more interesting? Maybe Jeremy can answer this.
Yeah, I think if we compare JavaScript and Go, I think one key characteristic of Go is the type safetiness. So the language is strongly typed, but still allow you, if you want to use like the unsafe package, to do some memory allocation by yourself. But by default, type safetiness is a key difference between Python and JavaScript, I would say, between those two languages, or those three languages. And then I think the Google team developing Golang have put security as a key factor of the language. And this is part of all the Go standard libraries, which is like the net package, the crypto package, the HTML package like Noah showed. They have created the key components so that people can develop applications securely.
Great. I also think it's a key differentiator that we are now supporting Go within the company. If I'm correct, Go like JavaScript and TypeScript, say the npm ecosystem, was our first thing inside how we wrote our own tools, and now Go is our second language where we write the core components in. Is that correct?
So I believe so. I know we have some Go developers as well.
Yeah, we have Jeremy on board, of course, but I mean, I think we have adopted Go as one of, I'm not sure if the second or the third language, but one of the languages that we develop internally in as well. Noah, I saw that you used both Snyk Monitor and Snyk Test. What is the key difference between the two?
Yeah. So Snyk Test actually returns an exit code, and based on that, you can put it in your pipeline and fail builds based on that if you have vulnerabilities or not. While Snyk Monitor continuously, it pushes the results to the UI. So first of all, you can see everything there. And second of all, it will continuously monitor that snapshot. So for example, with a log4j, whoever had log4j in their application and it was monitored, they got the email right away.
So basically what you say is when we do a Snyk Monitor, in this case, that would be an excellent thing. Like the point where you go to production and you say like, oh, okay, I'm done with this feature, I'm putting this in production, then a Snyk Monitor would make sense because now you're monitoring that snapshot, if I can call it like that.
Yep, exactly. It takes a snapshot of the dependencies. That's what.
Okay, and sends it over to your Snyk account so you can actually watch it there.
Exactly.
That's a great thing. So that does mean, I believe, that Snyk Test runs on your local machine and only gathers data and brings it back to you to see what kind of things we did wrong, right?
Yeah, so it would just give you the result locally on the terminal.
Yeah.
It would send the dependencies for Snyk to run and give you the reply locally.
That is a good thing to mention for everybody who wants to fix vulnerabilities. If you use a Snyk Test, it is great to do that on your local machine. But for the big fix, we need to register that you actually fix these things. So make sure that these vulnerabilities are first, or that project is first known by, for instance, doing a Snyk Monitor first, and then fix it, and then do a Snyk Monitor afterwards. Or even easier, connect your repository to it, fix it, test locally if it actually is fixed, which is always nice, and it runs, and then recommit it. That's another way. But with as far as I know, the Snyk Monitor is one of the tools that you can connect your application or your project to Snyk, so that we can actually see what kind of vulnerabilities they are. Folks, I want to thank you. I am impressed with this one. I loved the demo, the denial of service demo, and how easy it was that you how you fixed it. So thank you for that, and thank you, Jeremy, for assisting us as well. Are there any questions from your side?
How many people are on this right now? Maybe
There are over 40 people watching live. And that fluctuates of course a bit, but people jump on and off. Yeah, we've got a good hand. I'm not sure if this number is correct because we do it over 3 different platforms. So we're live on our Snyk YouTube, we're live on the DevSec on YouTube, and we're live on the on the Snyk Twitch. So thank you for doing this. And in the meantime, folks, if you're a Go developer, and we're always looking for a good developer, so you can apply with Snyk if you want to. But if you have it just like Noah showed us, make sure that you scan your applications, connect them to Snyk, and if you find a vulnerability, oh wait, in the meantime, I got this from one of the people from the back office. So because it's multiple platforms, it's more over 60 to 70 people now. So you did a great job. Thank you. I appreciate this so much, Noah. And funny thing is, you mentioned the advisor. And well, I already see somebody in my backstage area, which is Oren, which is one of the product leads of the advisor, and he will talk about that even further. So yes, if you were watching this, and you probably will hear Oren next to this also talk about Go support, but Noah showed us already. Nevertheless, the advisor is a great tool to look at if you want to include a package in your system. Before including it, see if it's vulnerable and what the health is and how many people are actually maintaining it. But hey, I will not go in further of this because, or else Oren has nothing to say to me anymore. Anyway, thank you so much, Noah. Thank you so much, Jeremy.
Thank you, Brian.
See you around. Stay around. If there are any questions, feel free, folks, to put them in the chat. And yes, those folks need to get back to other work, but I will relay the questions afterwards. So don't worry. Thank you so much. See you later. Cheers.